Epilepsy is a disorder affecting 60,000 people in the UK. People with epilepsy have sudden bursts of electrical activity in their brain, which causes what is called seizures. Seizures might vary depending on where this burst of electrical activity rises and then spreads. People with epilepsy are treated with medication, but unfortunately, in 30% of them, these medications are not working very well. Researchers like myself are trying to understand why these medications are not working using magnetic resonance imaging, or MRI. We are taking a picture of the brain with a person with epilepsy because he or she has started treatment, which makes him more likely to have a seizure. And then we repeat the same picture after 6 months since the treatment has started. We need to wait for 6 months because it's a time scale for us to understand if medication has worked or not. We then compare these two pictures and we look for differences which might explain why the treatment has worked or not. What we are measuring with MRI are metabolic changes in the neurons in the brain. In fact, neurons in the part of the brain where the seizure starts needs more oxygen as they increase their activity compared to when they are at rest. This is the same principle applied when you do sports. You need more energy, so then your body needs more oxygen to burn. The metabolic changing we are measuring with the MRI is called the hemodynamic response. The hemodynamic response is the ratio between the amount of oxyhemoglobin and the oxyhemoglobin you have in your brain. We usually call it blood oxygen level dependent or BOLD response. To see these metabolic changes, we need to process MRI images using advanced statistical methods, which makes the area of the brain with higher ratio brighter than the rest. In this research, we aim to demonstrate how MRI can be useful to predict whether a patient with epilepsy will respond to treatment or not, and ultimately to help doctors in guide their decision in which is the best medication to prescribe.